Math 1, Unit 8, Transformations, 8.3, Rotations. All right, here we go. A rotation is a transformation that maps all points of a figure around a point of rotation. A rotation is a turn. The shape retains rigid motion, which means size and shape. The image can be named using the following notation. So, a rotation is a turn. We can say rotate. Notice lowercase r stands for rotate. Triangle LMN to equal triangle L prime M prime N prime. Okay, or we could say something like this. We could say something to the effect of rotate triangle LMN. We could say 90 degrees about the origin. Or we could have some point. But a lot of the times, I think pretty much in here, almost every time we do a rotation, it's about the origin. So the origin is our point of rotation. Think about the center of your wheel on your bike. Okay, the center is the point of rotation. It's what it rotates around. And real quickly, if we're going to do a rotation, a great way to learn about it is with patty paper. So as we pass around a piece of patty paper, I'm going to do just some basics right up here at the top. I'm not a big fan of these two examples because when you're going to do a rotation, you have to have some reference of where you started. So what they should have done here on point P is they should have given you an X or a T there, because now we can tell how far we've rotated. So if I put my patty paper up there and I draw the line, I need a pencil because ink doesn't draw well. So whenever we're going to do a rotation, the first thing we should do is mark our point of reference. First thing you always do is mark your point of reference carefully, and then I will mark what I want to rotate with special care of making sure I mark the vertices. Now these aren't vertices, but I want to mark the end points. And then when I'm going to rotate, I can simply put my pencil or my pen on the point of reference and turn it. There I rotated it 90 degrees, and I could remark it here. Okay, and then I could go 180 degrees, 270 degrees, and then 360 degrees would bring me hopefully right back to where I started. Okay? All right. But let's get back right into what really we're going to be doing here. We're going to be doing some rotations on the coordinate plane. So reading this one, it says rotate triangle RST 180 degrees counterclockwise about the origin. Or another way of saying it is rotate triangle RST 180 degrees about the origin. All right, so let's start with this guy. Let's start using patty paper because it's a great way to kind of really see what we're doing. So the first thing I do is I lay my patty paper over the top, and I'm going to mark my point of reference, which in this case is the origin. So I carefully mark the origin. And then obviously I want to be really careful about where the patty paper, that it doesn't move. So I trace my, in this case, my triangle, holding that patty paper really steady. And then I mark my letters and really make sure I get the vertices, the corners correct. And now I'm going to move this 180 degrees counterclockwise. Oops. So there's 90 degrees counterclockwise, and there's 180 degrees counterclockwise. But look at my point of reference. It's off a little bit, so I got to make sure I bring it back and get it right on there. And so now I want to mark it. So what works a lot of it is I got to find that lattice point. So you can see my picture's off a little bit. I don't know if you guys can see it, but it's off a little bit, so I'm pretty sure it's supposed to be right there. So I'll adjust it and I'll put it right there. And then R looks like it's off and it's supposed to be right there. And T looks like it's supposed to be at 1,4, so I'll mark it there. And now I'll all right. So there I go. But you can see using the patty paper wasn't perfect, was it? So it would be nice if we have a rule that we can use, like we had for reflections. When we reflect over the x-axis, y stays the same. Excuse me, when we reflect over the x-axis, x stays the same, y becomes the opposite, right? So it would be nice if we could develop a rule here as well, so that we don't have the imperfection of using patty paper. So let's see what we've got here. So right now R started off at -3, -6, and now R is up here at +3, +6. And we had our S is at -5, -2, and S is currently at +5, +2. That's S prime and R prime. So 5, 2. And T is at -1, -4, and T prime is currently at +1, +4. Okay. So if we were going to write a rule for rotating 180 degrees, what do you guys think our rule could be for rotating 180 degrees? I'm kind of hearing it. It looks like they both become the opposite, right? So any point on triangle XY becomes the opposite of X and the opposite of Y. So that's our rule for rotating 180 degrees counterclockwise. And by the way, if I can get my patty paper back to where it was, we did counterclockwise, right? The other thing is we want to know is when we rotate counterclockwise or clockwise, it really doesn't matter, does it? Because think about your wheel on your tire on your bike. It doesn't matter if it's rotating forward or backwards, it's still going around the same points, right? Forward and backwards. You talk about rotating, forward, backwards, it doesn't matter. They all stay in the same position. So whether we're rotating 180 degrees counterclockwise or 180 degrees clockwise, it doesn't matter. All we do is we change the X and Y to the opposites. Easy enough? All right, so that's your rule for rotating 180 degrees. Let's go on to number 4 and let's use patty paper again to see what's happening here. So by the way, we have rotate quadrilateral GHIJ 90 degrees counterclockwise about the origin. Or we could write rotate quadrilateral GHIJ 90 degrees about the origin. So again, I take my patty paper. I'm going to first mark the origin, my point of reference. Make sure I mark that very carefully. And then I'm going to trace G HIJ. Make sure I trace that. Again, make sure your vertices are well marked. H, I, J, and G. And now I put my pencil lead on the origin, and I'm going 90 degrees counterclockwise. So pick up the corner and I just turn those once, and that's where my new line is. One way of using patty paper is I just going to take a push down really hard on the vertices. And now if I made a mark, I can pull it away and I can see, yep, there's G prime and H prime, and I prime should be Let's see, I kind of lost that one. I prime should be right there. And then J should be, I can kind of put it back and take a look. Looks like J should be right there. And now I'll connect those points. And all right, H, I, and J prime. Okay, how'd yours come out? Does it look like mine? Pretty close? All right, let's be honest. Doing this for some of us is easy, but it gets trickier, and some of us aren't too artistic, and so we're not really good about that. So again, just like rotating 180 degrees, it'd be nice if we had a rule that we could count on. So let's take a look. G is currently at -2, -1. Where is G prime? It is at 1, -2. Now this rule might not be as clear to you guys, but we'll figure it out. All right, H was originally at 4, no, that's 3, -1, and it's currently at 1, +3. And I started out at, where is I? Right there. It was at 5, -3, and now it is at 3, +5. And let's see, J was originally at 4, -6, and it is currently at 6, -4. All right. So take a look. G was originally at -2, -1, and now it's at 1, -2. H was originally at 3, -1, but now it's at 1, 3. And 5, -3 became 3, +5, and -4, -6 became 6, -4. Okay? And maybe the rule isn't too obvious. Anybody think they got an idea about the rule? What do you think? Negative yx. Very good. Any point on quadrilateral xy becomes negative yx, or I prefer, instead of negative, I prefer the opposite of yx. And here's our rule for rotating 90 degrees. Okay? If we're going to rotate 90 degrees, okay, we're going to switch our x and our y. So anytime you rotate 90 degrees, you switch your x and your y. Okay? But we rotated counterclockwise. So if we think about how does counterclockwise go, it goes this way, right? So if we rotate 90 degrees counterclockwise, my arrow is now pointing at the x value, right? So what I'm going to say is, when we rotate 90 degrees counterclockwise, our x and our y switch, and our new x becomes the opposite. So when you rotate 90 degrees counterclockwise, you switch your x and your y, and your new x becomes the opposite. Okay? Which means if we rotated, let me do that maybe over here, if we rotated 90 degrees clockwise, my arrow's pointing this way now, so the rule would be we switch x and our y, we switch our x and our y, and this time our new y becomes the opposite. So that's the rule for rotating 90 degrees. Anytime you rotate 90 degrees, you switch your x and your y, but if you rotate counterclockwise, your new x becomes the opposite. If you rotate clockwise, you switch your x and your y, and your new y becomes the opposite. Because think about it, counterclockwise, where is your arrow pointing? At the new x. Clockwise, where is your arrow pointing? At the new y. Okay? All right, so we'll continue, we'll get some more practice on that. Now I want to talk about the slopes a little bit. So let's go back to number 3, and we want to talk about rotating 180 degrees. Let's find a couple of the slopes. Let's start with Let's start with RS right here. So RS, we want the slope of RS, so we always do rise over run, correct? So the slope of RS is down 1, 2, 3, 4, and over 1, 2, which means the slope of RS is negative 4, 2, which reduces to negative 2. Can you guys see that? I know it's kind of down there. It's a little small. So RS is right here. And to get from S down to R, we go down 4 and to the right 2, which means negative 4 over 2, which reduces to negative 2. Does everybody have that down? Okay, now let's look at R prime S prime, which is right here. To get from R prime to S prime, we go down 4 and to the right 2, which is negative 4, 2, which reduces to negative 2. What do we recognize about the slopes of those two lines? They're the same. And think about that. Doesn't that make sense? If I have my pin here, my pen, and I rotate it 180 degrees, isn't it the same slope? Same slope, right? And if I rotate it another 180 degrees, it's right back to where it started, and it's the same slope. So when you rotate something 180 degrees, the slope doesn't change. The slope stays the same. All right, let's look at a 90-degree rotation. Let's take a look at JG. Where is the slope of JG going to go in? JG is right here. So what's happening in the slope of JG? Well, to get from J to G, we have to go up 1, 2, 3, 4, 5, and run 2. So the slope of JG is 5 over 2. Now let's go and find the slope of J prime G prime, which is right here. Let's see, where's JG? Here's JG. So how do we get from G prime to J prime? We have to go down 2 and to the right 1, 2, 3, 4, 5. So the slope down 2 means negative 2 and to the right 5. So what do we recognize about the slopes of these two lines? Opposite reciprocals, right? And last semester we learned opposite reciprocal slopes mean that the two lines are perpendicular. Perpendicular. Remember, perpendicular lines, if you guys can see that right down here, perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. You guys were supposed to learn that last semester. You must have had a lousy teacher. I don't know who that was. All right? Perpendicular lines have opposite reciprocal slopes. All right? Any questions on rotations? You're going to be rotating 90 degrees counterclockwise, 90 degrees clockwise, and 180 degrees counterclockwise or clockwise. It doesn't matter. All right.